Today we talk about a new topic, mathematical principle of mathematical induction. Mathematical principle of mathematical induction. Mathematical induction is a proof technique used to show that a statement is true for all natural numbers starting from a fixed number. Say n is equal to 1. Okay, now we are going to discuss the procedure to follow to use principle of mathematical induction. So we have a procedure to follow to use mathematical induction. So first thing, we are going to assume, let the statement to be proved. Statement to be proved. Let the statement to be proved be P of n, where n belongs to capital N. It's a natural number. The very first step, there are two steps. One is basic step, another one is inductive step. So base step, so what do you mean by base step or base case? The very first thing, verify that the statement is true for the first value. The statement is true for the first value means that is to prove P of 1 is true. So this one we can call it as base step. Step number 2, we talk about inductive hypothesis. Inductive hypothesis. So here we are going to assume P of k is true for some arbitrary value of k, greater than or equal to 1. Step number 3, inductive step. So here use the assumption. Here the assumption is P of k is true. Use the assumption. We are going to prove that P of k plus 1 is also true. P of k plus 1 is also true. So finally, we can give the conclusion as, hence, by the principle of mathematical induction, P of n is true for all n belongs to capital N. Okay. So these are the steps we are going to follow to prove the statement is true by using mathematical induction. So now we talk about one problem under this. Problem number 1. Problem number 1. The very first problem in mathematical induction is, use principle of mathematical induction, prove that 1 into 2 plus 2 into 3 plus 3 into 4 and so on, plus n into n plus 1 equal to n into n plus 1 n plus 2 divided by 3 by using mathematical induction. Okay. So already I told you what are the steps we are going to follow to prove the statement is true by using mathematical induction. So step 1, we are going to, first thing, we are going to write the given statement to be proved as true as P of n. P of n is equal to 1 into 2, 2 into 3, 3 into 4 and so on, plus n into n plus 1. So there are two steps we are going to follow to prove the given statement is true by using mathematical induction. So step 1, base step. So in this step, what we are going to do, we are going to prove the statement is true for the value n is equal to 1. That is, we are going to prove that p of 1 is true. P of 1 is true in the sense p of 1 is equal to 1 into 2. That is, which is equal to 2. This is your left hand side. What about your right hand side? Your right hand side is n into n plus 1, n plus 2 divided by 3. Put n is equal to 1 there, right hand side. So what we have? 1, 1 plus 1, 2, 1 plus 1, 3 divided by 3. So 3 get cancelled, which is equal to 2. So left hand side is equal to right hand side. Therefore, P of 1 is true. Therefore, P of 1 is true. So what about inductive hypothesis? We are going to assume that the given statement is true for k. That means we are going to assume P of k. The given statement is true for n is equal to k. P of k, that means 1 into 2, 2 into 3, 3 into 4 and so on, plus k into k plus 1, which is equal to k plus 1, k plus 2 divided by 3. So we are going to assume this. What about the third step? Inductive step. That is, we have used this assumption. We are going to prove that P of k plus 1 is also true. K plus 1 is also true. So what is P of k plus 1? P of k plus 1 is nothing but 1 into 2, 2 into 3, 3 into 4 and so on, plus k plus 1 plus k plus 1, k plus 2 equal to k plus 1, k plus 2, k plus 3 divided by 3. Okay. So we are going to prove that P of k plus 1 is also true. Okay. So first I can take left hand side. What is your left hand side? 1 into 2, 2 into 3, 3 into 4 plus and so on, plus k plus 1 plus k plus 1, k plus 2. This is your left hand side. Okay. So already we proved, we assume that P of k is true. That means from this to this, the given statement is true. The given statement is true means this is equivalent to what? K plus 1, k plus 2 divided by 3, which is equal to plus k plus 1 into k plus 2. Isn't it? So this is equivalent to, so you just cross multiply. So here k plus 1 and k plus 2 is common, so take it outside. So simply we have k plus 3 divided by 3. So we can assume left hand side and we can prove the right hand side. Therefore P of k plus 1 is also true. So finally, we can write the conclusion as hence by mathematical induction, hence by principle of mathematical induction, the given statement is true for all n belongs to capital N.